All right, so we're going to continue chapter 13. This is law of sines. Everything we did in the first 4 lessons dealt with right triangles specifically. And now we're going to look at situations where we have, in this lesson and in the next one, where we don't have right triangles. And so we're going to give you a method for solving them. So in other words, find all the missing parts. Right triangles are pretty easy. You can use the trig functions or Pythagorean theorem to find missing parts. If the triangles are not right triangles, it makes it a little bit more difficult. First of all, we're going to look at the area of a right triangle, And we all know that the area of a triangle is 1/2 base times height. Something that we've done a lot of work with, finding the area of triangles. And if we have a triangle that's not a right triangle, then we can still use that information and we can kind of alter it a little bit and use 1/2, and here they use these numbers here, that I can use it over here. We've got this triangle here that's not a right triangle. They give us the value of side C, which is 2.96. They tell us that angle A is 73 degrees and that the base is 2.13 meters. So this might be a sail. Okay? And I need to find the height of the right triangle to be able, of the triangle to be able to find the area. So if you remember, we know that sine is equal to opposite over hypotenuse. And if we look at the left side of this triangle, it is now a right triangle. They've drawn the height of it. What's the other name for a height of a triangle? Anybody know? Starts with A. It's called an altitude. Okay, so if you hear the word altitude, they're also, that would be the height of a triangle. So here it tells us the altitude is going to be the opposite side. The side that we know here between angles A and B is 2.96. And they know that angle A is 73 degrees. So I can use these numbers, the fact that this is now the hypotenuse of that right triangle, and here's my angle. So to find the height, I can do the fact that sine of A is equal to the height over side C. And if I multiply by C, then I have the height is equal to C times the sine of A. So what happens then is I'm just replacing, in this problem here, I'm replacing the height h with C times the sine of A. So in any triangle, if we know one side and we know the angle by it, we can use that to find the area of the right of the triangle. And basically we're looking at this. Okay, here's the 3 different formulas they give us. They say we can use 1/2 BC times the sine of A. All right. Notice the sides B and C and angle A. Or we've got the sides A and C and angle B. Or the sides AB and angle C. And what this turns out is that it is, if you remember from your geometry, this is side angle side. So if I know the side angle side of a triangle, any triangle, I can use this formula to find the area of that triangle. So we just do 1/2 times one side times the other side times the sine of the angle. So the letters don't make that much difference. It's the fact that I know 2 sides and the included angle, side, and I'm just going to find the area of the triangle by using that method. So here we have this triangle that has a 5-meter side, a 3-meter side, and 40 degrees. And so if I was to draw the altitude in here, then that would represent our height of this. And so I could focus on this right triangle here, and the height of that right triangle would be 3 times the sine of 40. So to find the area of the whole thing, we have 1/2 times the base, which is 5, and times the height, which is 3 times the sine of 40 degrees. And then all I have to do is just type that right in my calculator. So I make sure my calculator is, first of all, in degrees, right? Okay, because it says 40 degrees. And then just do 0.5 times 5 times 3 sine of 40. And we get 4.82 what? 4.82, okay, square meters, right? All right? It's still square meters, even though it's m to the second power. Make sure you say square meters. Okay, so there's finding the area of a triangle if we know a side, an angle, and a side. So you have to know those 3 parts in that order. Okay, side, angle, side. All right. Okay. Now, the law of sines is used to solve non-right triangles. In other words, find the missing parts. And if we take the area of those 3 formulas, different formulas, then we can actually use those to come up with a formula that allows us to solve the right triangle. And that formula is called the law of sines. Now, the law of sines can be used either way. You can either write it with the angles in the numerator and the side lengths in the denominator, or it can be flipped over and be the reciprocal. But this says that if I have the sine of angle A over side A, and remember those things are across from each other, right? Okay. Angles are always capital letters, side lengths are always lowercase. Then that's equal to the ratio of the sine of angle B over side B, and it's equal to the ratio of the sine of angle C over side C. So if we need to find other parts of a triangle, and given the particular information here, we can find the missing parts. Now, for the law of sines, we've got specific things we need to know. Okay? There is 2 angle measures and a side length are things that we need to know. That's one thing. So if I know angle, angle, side, or angle, side, angle, I can use the law of sines. Now there's a special case. It says 2 side lengths in the measure of an angle that is not between them, side, side, angle information. Now this one we'll look at separately because that's a special case there. And we'll talk about why, when you were in geometry, you could not use side, side, angle as a reason for proving triangles were congruent. All right, we'll talk about why. Okay, all right, you probably don't remember that, do you? Okay, all right. We used angle, side, side. We used angle, angle, side, and angle, side, angle to prove that triangles were congruent. But in geometry, we said you cannot use side, side, angle. All right, so using the law of sines. It wants to solve each triangle round to the nearest tenth. Right? So when it says solve the triangle, that means we're trying to find all of the missing parts. So here they give us 2 angles and a side. And we want to find the other angle and the length of the 2 missing sides. So I know angle, 28-degree angle, 33-degree angle, length of the sides 15. So that's angle, angle, side. So I can use the law of sines. So I'm going to set up the law of sines here, but my letters I'm going to use are E, D, and F, or D, E, and F. So we got this sine of angle D over side D. So the first thing I'm always going to do is write it out using the letters they give me. That way I've got them all written down. Okay? And always capital letter, angle, lowercase letter, side length. So I just wrote out the law of sines in using those letters. Now I'm going to fill in what I know. Angle D is 33 degrees, so I'm going to put 33 in there. Side D, we don't know. Angle E, they don't tell us. All right. Or do they? Do they tell me angle E? What? Technically they do, because why? Right, okay? All angles of a triangle add up to 180 degrees. So if I take 180 minus 33 and minus 28, we get angle E, which is what? 119, okay? And side E, we don't know what that is. All right. Angle F is 28. And side F is 15. So we plug in what we know, right? Then there's got to be at least one of those ratios has to be complete. Okay? One of the three has to be complete. And then what we're going to do is we're going to take the one that's complete with the other two and solve. So I'm going to do sine of 33 over D equals sine of 28 over 15. I'm going to solve that proportion. And then I will solve the other one. Sine of 119 over E is equal to sine of 28 over 15. So the proportion the ratio that you find, you're going to put that with that's complete, you're going to put that with the other two of them that are incomplete and solve to find the missing parts. Okay. So then we just cross multiply. So we get 15 sine of 33 equals D times the sine of 28. Or 15 sine of 119 equals E times the sine 28. Okay, so we cross multiply, and then what do I do after I cross multiply then? Okay, all right, I have to divide then to get the variable by itself, so we're going to divide by the sine of 28. And when you're doing this on your calculator, you can do it all in one step. So 15 sine of 33. Just make sure you close the parenthesis here, and then divide by the sine of 28. And 15 sine of 119 divided by the sine of 28. Now, one of the things that we want to talk about too while we're doing this is numbers that make sense. Okay. Always good to have numbers that make sense, right? Okay. All right, so we've got side E. So E is approximately 17.4. Oop, that was D, excuse me. And side E is approximately 27.9. All right. So if I go back to my triangle, so this angle here was 119, And my side lengths here, E was 27.9 and D is 13.4. Okay. Oh, 17. Now I need to make sure that those numbers make sense. Okay? And how do I know in a triangle whether the numbers would make sense or not? The bigger the number, the longer the side. Okay, and how does that compare to the angles? Exactly. Okay? The longest side is always going to be across from the biggest angle. The shortest side is always going to be across from the smallest angle. So you need to make sure that that happens. Okay? Because sometimes you'll get things mixed up and it doesn't make sense. Right? So make sure you always have the largest side across from the biggest angle, smallest side across from the smallest angle. Right? And if I reset those up on my triangle like I did, we can see that that's true, that I got that. Okay. All right, let's do another one then. Okay, so here we have triangle P, Q, and R. So once again, the first thing I'm going to do is rewrite the law of sines with using those letters. Now here we know we have it written as angle, side, angle. So this is our ASA, angle, side, angle. All right, can I use the law of sines for that? Yes, we said that I can for angle, side, angle. So once again, they give me two angles, so I need to find the third one. What's the third angle in this case then? 105. Right? So if that's 105, what does that tell you about the 10 then? Okay, it's the longest side. So if I get Q or R that are greater than 10, I made a mistake. Okay? So you need to think about that when you're doing these. All right, so we've got the sine of 105 over 10 equals, Q is, must be 36, huh? I don't have a Q here. This must, here's the Q, there's the little R, there we go. That would be better. Okay. So the sine of 36 over side Q. All right. And here, once again, we don't have side R, so I'm going to go ahead and write, put the sine of 105 over 10 equals the sine of 39 over side R. So the one proportion, the one ratio that I know everything is with the P's. I'm missing side Q and side R, so I'm going to take that complete ratio and put it with the other two. And then we just cross multiply and solve. And since we're rounding to one decimal place, right, then it's going to be an approximate answer. It's not going to be an exact answer. So when we're done, which is going to be bigger, Q or R? Well, you should be able to tell from down here. Okay. Okay. Sine of 39 over R. So 39 is the angle with side R, so R should be a little bit bigger than Q when you're done. So we've got, let's see, 10 sine of 36 divided by the sine of 105. What if I got a negative answer? Would that make sense? No, because side lengths can't be negative, can they? All right. So if you got a negative answer, what would I need to check on my calculator then? Yeah, whether you're in degrees or not. I need to check the mode. All right. All right, so we get 6.1. And if we do the other one, 10 sine of 39 divided by the sine of 105. Oops. So we get 6.1 and 6.5. And that would make sense as far as our length. So we had to find three things here. We had to find angle R, or side R, side Q, and angle P. So the measure of angle P was 105 degrees. And whenever you're doing the angle, then you should always write it like this. Okay? Measure of angle P. Use that angle symbol. All right? In your book, when you use an angle symbol, they just kind of make it look like that. That looks like a less than sign to me. So I always put a little arc through it to represent an angle then, so I can see that as an angle. All right, so my answers would be, for this question, I have three answers. Measure of angle P is 105 degrees, side R 6.5, side Q 6.1. Okay, one of the things that, if you remember in geometry, you learned that you can't use SSA as a theorem for solving or for proving that triangles are congruent. And here's the reason why. Because it's ambiguous. Okay? Because there actually could be more than one triangle that is drawn when you know side, side, and an angle. Okay? And here are all the different possibilities it could be. We could end up with this situation here. All right, first of all, we have acute angles. Okay? If our angle A is an acute angle, and we have angle A here, is always going to go down, start here. Side B is always going to be like the hypotenuse for that. Okay? And side A would be opposite that angle. Right? Well, they use H as the height of the triangle then, okay, or the altitude. If A is less than H, then there's no triangle. Okay, well, how do I find H? How do I find H? They got H up here, but they don't tell us how to find H. Anybody know how to find H? What does H equal? And it is, okay? Except it's not C, right? It's going to be, H is the height, right? Okay? And H is the, if I know angle A, then the altitude in this case is the opposite side, and B is the hypotenuse of that right triangle. So I would take the hypotenuse and multiply it by the sine of the angle. So that's just like what we talked about in finding the area, okay? That the height, the value of H here, is just basically B times the sine of angle A. Right? So if A is less than H, there is no triangle. If A equals H, right here, then there would only be one triangle. Okay? And it would be a right triangle. If A is greater than H, but less than B, then there's two different triangles. And if A is greater than B, then there's one triangle. So here's the reason why you can't use side-side angle as a way to prove congruency, is because there's 6 different possibilities it could be. So there's no way that you could use it for the proof there. If it's angle A is right or obtuse, if A is less than or equal to B, there's no triangle. And if A is greater than B, then there's one triangle. So when you're working with this ambiguous case, right, first of all, we're looking at, is it acute or is it obtuse? Right, for the triangle, it all depends on angle A. And then we need to find the value of H and see how it compares. So here we go. We have this art application we're going to use for this. It says, determine the number of triangular banners that can be formed using the measurements A equals 50, B equals 20, and the measure of angle A is 28 degrees. And it says, solve the triangle or triangles, and round to the nearest tenth. So we know A is 50, right? B is 20, angle A is 28 degrees. Well, oops, missed a little bit there. So the measure of angle A is acute, right? It's less than 90 degrees, so it's acute. Right? So that means I have 4 possibilities that could be here. One of those 4. So let's find the value of H. Okay? And H is always going to be B times the sine A in these cases. Right? The side not opposite from it, and the angle that we know. Right? Which they may use different letters. So you're going to have to figure that out. All right? So that means we're going to do 20 times the sine 28, and what do we get? $9.38. All right. So we need to compare those lengths. Right. So is A less than H? Nope. A is 50, H is 9.38. Is A equal to H? Nope. Is A between H and B? Nope. So it says A is greater than B, 50 is greater than 20. So that means then we're going to be that there is then one triangle. And we're going to solve that one triangle then by using the law of sines. So the sine of angle A over side A, sine of angle B, side B, sine of angle C over side C. So once again, the first thing I'm going to do is start out using the letters that they give me to write out the law of sines. And then plug in what we know. Let's see, we know angle A is 28 degrees, all right? And side A is 50. Let's see, we don't know angle B, but we know that side B is 20. And we don't know anything about the C's. So let me ask you this. Yes? That's a very good question, because you know what? I was actually going to bring that up. Can I use the Pythagorean theorem to find side C? Why not? Oh, it's not a right triangle, okay? It's not a right triangle, so no, I can't. Okay? So let me ask you this. All right, before we do anything else, let's think about reality of the situation so that I know that when I find answers, that my answers will make sense. Right? Is angle B, is that going to be less than or greater than 28 degrees? Is angle B going to be less than or greater than 28 degrees? Logan? Why? Because 50 is bigger than 20. Okay? If this side is 50 and this side is 20, then the angle that goes with the 50 has got to be bigger than the angle that goes with the 20. Okay? All right. So what does that tell you about angle C then in this case? It's got to be bigger, doesn't it? Because 28 and whatever this one is, whatever B is, it's going to be pretty small. So angle C is going to end up being larger than 90 degrees. It's going to end up with the biggest one. That's all I really need to know. Okay, that's going to be the largest angle, and then side C is going to be the largest side. Right? So we need to make sure we take those into account. So, answers. All right. So we'll take the one we know and we'll cross multiply. Do our work here. So we're going to focus on, so 20 times the sine of 28 is equal to 50 times the sine of B. Right? I can't do anything with the C's, can I? Yet, because I don't know anything about the C's. So we divide by 50. Oh. So the sine of B equals, and when you find this number's got to be less than what? Less than 1, okay? Because whenever I find the sine of an angle, it's got to be less than 1. So my number there, I find better be less than 1. So 20 times the sine of 28 divided by 50 equals 0.1878 or 1.877886251. Okay. Now, if you're going to write any numbers down, you need to write four decimal places. Okay? So 1878. I'm going to write that down. Well, then how do I find angle B? Okay. Well, not the sine -1, but the inverse sine. So I'll take my calculator and I'll do the inverse sine, so second sine. And what number should I put in there? I should put in the whole thing, shouldn't I? All right. So how do I put in the whole thing the easiest way? All right, second negative sine, so inverse sine of the answer is what I want. And we get 10.8 degrees. So angle B is 10.8 degrees. So now we can find angle C. Right? So 28 plus 10 is 38. Okay. And 38.8 subtracted from 180 is? Okay. So now I can use that sine of 28 over 50 equals the sine of 141.2 over side C. I can put my complete part with the A's, and now I know angle C, so I can do cross multiplying then to find the other side. And that better be longer than 50. Okay, when I'm done. And it is. Side C is approximately 66.7. Okay, and in this case, that's 66.7. Doesn't say.